Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. This is our 10th class for this subject, ERS 5950, and we are approaching towards the end of our semester. And most of you have already received your assignment 5, and some of you already have submitted your assignment 6. Right? And for assignment 5, this morning I have released the score for your assignment 5, so you can check for your score. And once we have got all the assignment 6, then I will release the assignment 6. All right, so the last topic that we have discussed last week was on chi-square. We have completed our discussion on 2 different types of chi-square. The first one was chi-square for goodness of fit. Second was chi-square for test of independence. We didn't discuss on chi-square for homogeneity because it is basically very similar to your chi-square for test of independence. It's just a matter of the focus or the purpose will be different. I mean, for test of independence, we are testing on the relationship between two variable, whereas for the test for homogeneity, we are testing or we are comparing differences among group. I mean, that are the two major that will be the major difference between goodness of the test of independence as well as test of homogeneity. So today we are going to proceed to a new topic, and the topic will be Spaerman row correlation. And this topic will be the third last topic for our subject. We have 2 more topics to be discussed. One will be Pearson product moment correlation, and the last topic to be discussed will be simple linear regression. So once we have completed all our topics, and once we have covered the 14 classes online, then we should be able to sit for our midterm exam, final exam. Midterm or exam done, final exam. So how are you for today, this morning? You have taken your breakfast? Done? Inshallah. So different people have their own breakfast. So hopefully your stomach is already full, so that we can stay at least up to about 12 o'clock today, inshallah, for our class. Okay, so that means starting from chi-square, Spaerman row correlation, Pearson product moment correlation, and finally simple linear regression, the focus will be on relationship between two variable, IV and DV. I still have few, not many, of our friends, even in assignment 6, wrong choice of DV. Wrong choice of DV for the last equation. So that means if you choose the wrong variable for your DV, then you will get 0 for that particular question. So for your chi-square, since we have only 2 questions for assignment 6, so question 1, 5 points. Question 2, 5 points. That means if you choose the wrong variable for your DV, 5 points will be gone for good, right? So that will affect the overall of your grade, especially for those who didn't do well in the midterm exam. So we want to capitalize. The assignment score, so that will further improve your overall grade. So make sure choose the right variable. Maybe you can discuss with your friend, make sure you are selecting the right variable. Otherwise, unnecessarily, 5 points will be gone. So that means, hopefully, starting from every time starting from Spaerman, which will be the topic today, and then Pearson and simple linear regression, we will not incur the same mistake. But majority of you are okay, but few still have that problem to decide on the right variable for the DV. Remember, we mention all the time, that for assignment 1 data, our DV is participation. So don't choose other variable except for participation. The IV you can choose among the IVs that are available in that data set, but we have only one DV, and that DV is participation. So we hope that nobody will make any mistake in selecting the right variable. Otherwise, unnecessarily you lose 5 points, maybe you lose 3.5 points, or whatever point that we allocate for the last question, right? Okay, and then just to make sure that we get, I have already posted one reminder in our WhatsApp, so that, when you work on your assignment 7, 8, and 9, make sure any appendix that you want to attach must be placed at the back of at the end of the answers. That means we don't want to have appendix or any output in between your answers. Just answers to answer your question according to the sequence. Make sure also to answer according to the sequence given in the assignment. Let's say A, B, C, D. So if, let's say, in A, you are supposed to present the complete table, then you should present the complete table in A, not to present the complete table in D. So that is one thing. Make sure you answer in sequence. Second, make sure if that you want to place, because that is a requirement that you need to attach the appendix. So appendix, the word appendix itself indicate it should be at the end of your answers, right? Appendix shouldn't be in between. So if it is in between, it distorts the flow of your answer. So make sure if you incur any mistake in incorporating the output as well as the answers, then Tok Mudin will be available in service. Tok Mudin. Who is Tok Mudin? Tok Mudin will, the function of Tok Mudin is to cut something, right? And this one is to cut mark. So make sure when it is answers, just answers without any output in between. Output place as appendix at the end of your answers. Is it clear? Nazihah dah ngangguk kan? InsyaAllah. Kalau ketua jabatan dah ngangguk tu, yang lain dah kena follow lah. Okay, so now, any question on your chi-square, if there's any? So chi-square is non-parametric statistic, and the topic that we are going to discuss today is also non-parametric statistic. I mean, we have only two non-parametric statistics in our subject, which are one, chi-square, already done last week. And for this topic for today, we are going to discuss another non-parametric statistic, which is Spaerman row correlation. Okay, if there is no question, make sure it's already recorded. Okay, I have already recorded the session. So let me change to the notes. All right. So make sure use the new notes that I have uploaded, because the one that I have uploaded earlier, there was some mistake. So I have already cleaned up the mistake, and you can throw away that version, that earlier notes. Use the more recent notes for your Spaerman row correlation. Okay, so let's go for the topic. So this topic is actually very straightforward. Very straightforward, and if you just follow me to follow the step-by-step procedure, naturally you don't have any problem in doing your in mastering this topic, and for you to work on your assignment as well as to later on respond to the question in your final exam, inshallah. So the topic is Spaerman row correlation. I mean, the word here is correlation. I mean, correlation here refer to relationship between two variables, X and Y, IV and DV. Okay, so as an introduction, this statistic, Spaerman row, is also called as rank ordered correlation. Spaerman row correlation is also known as rank ordered correlation. Why it is called rank ordered correlation? Because the calculation is based on ranking of your score. I mean, here, remember when we did our calculation for chi-square, the calculation is not based on score, remember? Najib, what was the basis for our calculation? Najib, dah minum lah kan? Okay, Najib, what is the basis for calculation?
For Spaerman rule or what?
No, for chi-square, the one that we have discussed last week, the one that you have already submitted for your assignment.
Expected value row total minus column total divided by grand total.
So basically the calculation is not based on score, but the calculation is based on frequency. Yeah, based on frequency. We have two different type of frequency, O and E. O is observed frequency, E is expected frequency, where in order to calculate for the expected frequency for the goodness of fit, the formula is E equal N multiplied by P for goodness of fit. But for test of independence, as mentioned by Najib just now, E equal row total multiplied by column total divided by grand total. I mean, we have only our calculation is based on two different type of frequency, observed and expected. Here, in this case, most of the time our variable are either interval or ratio scale. But we don't calculate based on the score, but our calculation will be based on rank of X and rank of Y, ranking of X, ranking for Y. I mean, one of the characteristic of non-parametric is our calculation is not based on score. Our calculation is not based on score. In this case, our calculation is based on rank of X as well as rank of Y. So as what we experienced last time when we were in school, those who are clever will be ranked number 1, right? Or number 2 or number 3. But those who are not that clever will be ranked last in the class, right? I mean ranking based on the score. Afterward, I will share with our group here the crucial part, which is how to do the ranking, how to assign rank to your X, rank to your Y. Ada a few more coming in. Okay, so the purpose here, the purpose of using this Spaerman row correlation is we want to determine a relationship between two variables, and these two variables is based on ranking for X, ranking for Y. And then the requirement, the basic requirement for your Spaerman row is both IV and DV is actually ordinal scale. Ordinal for the IV, ordinal scale for the DV, because it is rank ordered, because it's rank ordered. But originally, the data for your opinion X and Y will be either interval or ratio scale. Both IV and DV, the score for your IV and DV will be either interval or ratio scale. But here, the case that by right, if it is interval ratio, a better statistic, if the distribution for X and Y are normal, then a better statistic will be for you to apply Pearson product moment correlation, because Pearson is parametric statistic, Spaerman is non-parametric statistic. But when is the case that we need to apply for this Spaerman row? When one of the variable, either X or Y, either the IV or the DV, the distribution is not normal. The distribution is not normal. Then we apply Spaerman row. But if both are normal, a better statistic will be Pearson product moment correlation. But in case one of the variable or both the variable, the distribution is not normal, even though the scale of measurement are interval or ratio, but if the distribution is not normal, then we go for Spaerman row correlation. But what happened yesterday class, somebody asking me, if both are normal, let's say if we check for when we want to run for the assignment 7, we have already identified X and Y. When we check for the assumption of normality, both the variable are normal, are normally distributed. Can we apply Spaerman row correlation? Can we apply? Yes or no?
Can.
Yes, the answer is yes. But it is considered as macro. It's not haram, it's macro. But if the distribution is not normal, can we apply, if the distribution is not normal in one of them or both of the variable, distribution is not normal, can we apply Pearson product moment correlation? Yes or no? The answer is no. That means if you were to apply, that is considered as haram. See, haram if both one or both of the variable distribution is not normal, we want to apply parametric, which is in this case Pearson. We can't, because it doesn't meet the requirement, because Pearson product moment is parametric statistic. But for Spaerman row correlation, the basic requirement will be both are interval ratio. At least one of the variable must not be normally distributed. Can be one or can be both. But since this is non-parametric statistic, which another name for the non-parametric statistic is what? Distribution-free statistic. Another name for non-parametric is distribution-free statistic. That means regardless whether the distribution is normal or not normal, we can still apply the non-parametric statistic. So hopefully that is clear to everyone, whether we can apply Spaerman for normally distributed data or only for non-normally distributed data. So hopefully everyone will be clear by now, Zirat. Let me repeat just to make sure. If both are not normal or one of the variable is not normally distributed, then of course you need to apply for Spaerman row correlation. But in case if both the distribution for the variable x and y are normal, we can still apply for Spaerman row correlation, even though a better option will be for you to apply for Pearson product moment correlation. But if you still insist you want to apply for Spaerman, no harm, because that is considered as macro. Syuhada, clear? Is it clear to you, Syuhada? Syuhada tak cukup light tu. The lighting is not enough.
Prof, now your internet connection is putus-putus.
Oh, ya,
so I can hear your voice. Yes.
Saya nampak okey je kat sini. Is mine or is yours? What about the rest?
Prof, I think it's yours.
Is it mine? My internet connection is not good or not stable, or yours not stable? Because mine is just
yours
okay.
is unstable.
Yours, Professor. Your internet not stable.
Oh, yeah.
Because the video also hang.
Because I can see on my, I can see here, I can observe on my on handphone. It looks smooth.
Yeah, me too.
Now, okay, Prof. Before this.
Okay, but you can still continue. Okay, you can still follow me. Is that right?
So can you repeat again, Prof?
Which one?
Revise back. Which one normal, not normal?
Okay. We are talking about the requirement. Is that right? Okay. The basic requirement here, IV DV is ordinal and ordinal. Why ordinal? Ordinal because we rank score for X, we rank score for Y, is that right? Therefore, when we rank, it becomes ordinal scale. But in reality, when is the case that we need to apply for Spaerman row correlation? When both IV and DV, the scale is either interval or ratio. Interval or ratio. But if it is interval or ratio scale for both IV and DV, if the distribution are normal, if the distribution are normally distributed, then a better statistic will be Pearson product moment correlation. Because why? Because if both are normal, that means we can apply parametric statistic. But when is the case that we need to apply for Spaerman? The case is when one or both the variable, the distribution is not normal. The distribution for X or Y, not normal. Then we apply for Spaerman row correlation. But the question earlier that I posed to Najib, can we apply Spaerman row if both the variable are interval ratio, and both the variable distribution is not normal? The answer is yes. Because why? Because even though a better option will be Pearson product moment correlation, but if you were to apply for Spaerman row, it is still acceptable. Because why? This is considered as macro. Remember, not haram. It's macro. So we can still apply for Spaerman row, even though distribution for X and Y are normally distributed. So is it clear by now? Okay, that will be in terms of the requirement. So basically what you need to place on your memory will be the requirement for Spaerman row correlation will be both IV and DV are interval ratio. But basic requirement will be at least one of the variable, the distribution is not normal, at least. But if both are normal, then we can still apply. That is considered as, oh, now I can see my internet is unstable. It give the message now. Okay, so that is the requirement. Okay, let's proceed further. Okay, this slide gives you the overall picture of what to expect for Spaerman row correlation. Okay, not that much, right? Only on one slide. Then that is what we need to understand about Spaerman row correlation. Okay, for Spaerman row correlation, it has two dimensions: descriptive dimension as well as inferential dimension. Descriptive, inferential, as compared to what we have discussed earlier for t-test, ANOVA, chi-square. All these statistics are inferential statistic. T-test is an inferential statistic. ANOVA is also inferential statistic. Chi-square is also inferential statistic. But Spaerman row has both a dimension, descriptive dimension as well as inferential dimension. Okay, what constitute the descriptive dimension of Spaerman row correlation? Okay, what we need to do here for this descriptive, first of all, we need to calculate or we need to derive. Why do I say we need to calculate or we need to derive? We need to calculate if we were to do manual calculation. We need to derive if we were to use SPSS, right? Okay, that means the first thing in the descriptive component for Spaerman row will be, we want to calculate, if we are doing manual calculation, what is it that we need to calculate? We need to calculate RS. What is RS? RS is Spaerman row correlation coefficient. Spaerman row correlation coefficient. Or if we were to use your SPSS, then we don't need to do any calculation. We just run the analysis and then we extract, we derive from SPSS output. That is the first thing that we need to do. Second, once we have derived that RS, the value for Spaerman row correlation coefficient, then we need to describe. What is it that we need to describe? We need to describe the direction as well as strength or magnitude of your relationship. That means we are going to describe two things: the direction of the relationship, either positive or negative, and the strength. Whether the strength, we can use the one that we discussed last week using Guilford rule of thumb. Still remember? Guilford rule of thumb to describe the strength of relationship between X and Y. What does Guilford rule of thumb says? If it is less than 0.2, negligible relationship, 0.2 to 0.4, low relationship, 0.4 to 0.7, moderate relationship, 0.7 to 0.9, high relationship, more than 0.9 up to 1 will be very high relationship. That means we can describe direction. The direction will be based on the sign of your RS. If it is negative, negative relationship. If it doesn't indicate any sign, understood that is positive. I mean, either negative or positive. And then also we discuss on, or we present the strength using Guilford rule of thumb. We are not going to use Cohen, even though Cohen is another decision criteria that we can use. But for our class, we focus, or we specify on only Guilford rule of thumb, right? Guilford rule of thumb. Okay, now, when you go for t-test, t-test ranges, Naziha, t-test ranges between, t-value ranges between, Naziha can still remember? T-value ranges between?
Minus infinity
plus infinity, that's right. When we go for F ratio in ANOVA, F ratio ranges between, anybody? F ratio ranges between?
0 to infinity.
0 to infinity, that's right. When we proceed last week on the chi-square, what was the range of value for the chi-square? Chi-square ranges between, pardon me? Chi-square ranges, somebody mentioned something just now, but I can't get you.
0 to
Chi-square ranges between?
0 to infinity.
0 to infinity. That means similar to F, chi-square also ranges between 0 to infinity. These are favorite question in our final exam, part 1, knowledge. So remember, T ranges between minus infinity to plus infinity. That's why we need to worry about whether we are testing for 1 till or 2 till, because it can be negative, it can be positive. But when we go for ANOVA, when we go for chi-square, because the value will always be positive, therefore we don't have to worry about 1 till or 2 till. We just test only one hypothesis. There is no direction, indication of direction. Okay. And then once we go for this Spearman rho correlation RS ranges between -1 to +1. RS Spearman rho correlation coefficient ranges between -1 to +1, not minus infinity to plus infinity, but -1 to +1. The plus and minus to indicate the direction, whether positive or negative. The absolute value will indicate the strength of relationship. Okay, that will be the two things that we need to do when we go for descriptive component for Spearman rho correlation. Calculate or derive RS and then describe. What is it that we need to describe? We describe the direction. We also describe the strength of relationship between X and Y. That will be descriptive component. The second will be inferential component. What constitute inferential component? What do you mean by inferential component? We are talking about testing for hypothesis, right? Okay, but here we have two procedures for our testing for hypothesis. And the two procedures depend on sample size. If your sample size is less than 10, then we use this 5-step procedure. But if your sample size is 10 or more, then we go for this second step procedure. Right? So that means we still have the 5-step procedure, but for n less than 10, that means we use the first procedure. If it is 10 or more, then we use the second procedure. Okay, let's look at the 5-step procedure. If your n is less than 10, okay, what should be step number 1? Step number 1, as usual, will be state HO/HA. That means we state the null and alternative hypothesis. Step number 1. Step number 2, we don't need to calculate additional statistic. We just report the RS that we have calculated earlier in descriptive component, and then that will be your step number 2. We don't need to internet unstable. Can you still follow me?
Prof, your slide tak
Slide tak keluar?
still in the Spearman rho jadual.
Spaerman rho jadual. I'm now actually in the mapping, mind mapping on Spaerman rho. By right, you should see this. Is it right? Okay. Okay, but whatever it is, you may want to open your notes so that you can refer to the notes in case if the display doesn't jive with our discussion. Okay, coming back, if your sample size is less than 10, step number 1, as usual, will always be state HO/HA, step number 1. Step number 2, we just report RS that we have calculated earlier in our descriptive component, right? We just report the value for RS. And then step number 3, we need to go to your statistical table. Okay, open your statistical table. Open on page 14. Open on page 14 of your statistical table. Page 14. Everyone, please open your table, page 14. And that the title is Spearman rho. Spearman rho. Nampak semua mahfuz doesn't move. Syuhada doesn't move. Nabila baru move sikit-sikit. So everyone, can you follow me now? Can you hear me? Okay. All right. So make sure open your table page 14. This is your table for Spearman rho. If your sample size is less than 10, then in step number 3, to determine the critical value, this will be the table that we need to refer to. This will be the table. Okay. Okay, let's say now we are testing at alpha equal 0.05. let's say, I mean, as an example, we are testing alpha 8.05. We are testing for two-tail. We are testing for two-tail, and our sample size is 8. What should be the critical value? Alpha 0.05, two-tail, and our sample size is 8. What should be the critical value?
0.738.
0.738. That's right. I mean, you need to refer to the table to the table on the left, right? Because on the left is two-tail. But if let's say now you are testing for alpha at 0.05, but you are testing for one tail, and your sample size is 7. What should be the critical value? Sample size is 7.
0.714.
0.714. I mean, in this particular case, for sample size less than 10, 0.714, then this will be the table for you to refer to. But remember, this is only if the sample size is less than 10. In step number 1, we state the null and alternative hypothesis. In step number 2, we just report the value for the RS. Step number 3, we present the critical value for the RS. Step number 4 will be decision by comparing the calculated RS against critical RS. We should be able to make our decision, normal decision criteria. And then finally, conclusion, if your sample size is less than 10. But what happens if your sample size is more than 10 or more? If it is 10 or more, then we follow the same, we follow up in another 5-step procedure. The first step will be similar, identical. State HOHA, step number 1. Step number 2, in step number 2, we don't report RS, but we need to calculate another statistic. If your sample size is 10 or more, what is that statistic that we are going to calculate? We are going to calculate T statistic, T value. Right? We don't simply extract the RS and then report it here. No, because our sample size is 10 or more, therefore we need to calculate T. So how to calculate T? In order to calculate T, okay, you don't have the, let me admit one person. Okay, you don't have in your formula sheet. Okay, please open your formula sheet for Spaerman row. For Spaerman row, okay. For Spaerman row, only one formula there. Is that right? On page 6. On page 6. Where RS equal 1 minus 6 summation D square divided by N square minus 1. That is the formula to calculate for RS in your descriptive component. But if your sample size is 10 or more, then we need to calculate T. But the T formula is not given here. Is it right? The T formula is not given here. But the T you can refer to Pearson correlation. Under Pearson correlation, if you refer to page 7, T equal R minus rho divided by square root of 1 minus R square divided by N minus 2. All right? Now that is the formula. That formula we apply here. But instead of R, we change that to RS. Instead of rho, rho S. And then instead of R square, RS square. We just include the subscript S to indicate these are Spaerman rho. That means we are using the same formula for Pearson product moment correlation in calculating the T value. Right? Okay, that will be in step number 2. Calculate your test statistic, and that test statistic will be T. And to calculate T, we share the same formula in Pearson product moment correlation, but we just insert the subscript S, RS, rho S, RS square. Everyone get me? Do you get me? Sandra, can you follow me? Okay, that means don't be panic when you go for your final exam later on, because hey, where is the formula to calculate T? Okay, I have already informed everyone. What is our time now? Our time now is 9:38 or 9:37. So I have informed the class members that the formula for T for Spaerman rho will be similar to formula for T in Pearson, but we just insert the subscript SSS, RS, rho S, and RS square. But everything will be the same. Okay, that is step number 2. Step number 3, we determine critical value. To determine critical value, now we go for the normal T table. What is our normal T table? On page 9. I mean, if your sample size is 10 or more, then we refer to the T table in order to determine critical value. And we are already familiar with the T table, then I don't have to share how to determine the critical value based on the T. And step number 4, decision. For decision, we just compare T calculated in step number 2 against T critical in step number 3. And finally, our conclusion. That will be the 5-step procedure for if your sample size is less than 10 or if the sample size is 10 or more. So make sure before you do anything, if you have identified in the exam that this is meant for Spaerman row, make sure decide whether to use the first procedure or to use the second procedure, the 5-step procedure for the first or the 5-step procedure for the second. Right? Okay, that is basically what you need to expect for Spaerman row correlation. So while we digest the information, and if you have any question that you want to pose or you want to get clarification, now we go for plenary session. Oh, is it because of the internet connection is unstable that none of our members the camera is on?
No, no,
Yeah.
mine is on.
Yours is on, but I can't see you. Maybe because of the internet connection. Okay. So any question? Any question about the what we have discussed so far? So that are basically what you need to understand about Spaerman row correlation. Remember, make sure we know what is the purpose of using Spaerman row correlation. Make sure we are certain about the requirement. What should be the scale of measurement for the IV and the DV, and then make sure we need to know the 2 dimension of Spaerman row, descriptive and inferential. What is descriptive? We calculate or derive RS, and then we describe. What is it that we need to describe? Direction as well as strength. And then the inferential component, we are testing for the hypothesis. We have 2 procedure 1, procedure 2. Whether to use procedure 1 or procedure 2 depend on your sample size. If it is less than 5, then you use the first procedure. If it is less than 10, not 5. If it is less than 10, then you use the first procedure. But if it is 10 or more, then we use the second procedure. In the first procedure, we don't need to calculate additional statistic in step number 2. We just report the RS. But for sample size 10 or more, then we need to calculate another statistic, and that statistic will be T value. How to calculate T? We share the same formula as in Pearson product moment correlation. Okay, so any question? I open for any clarification if you have any. None. Okay, kalau tak ada kita terus. If there is no question, then we continue our discussion. Okay, proceed further. Okay, what to expect? First of all, we calculate RS. How to calculate RS? The formula is 1 minus 6 summation D square divided by N square minus 1. That is the formula to be used. And this formula is in your formula sheet. Right? RS equal 1 minus 6 summation D square divided by N square minus 1. I mean, in this case, we have 2 variables that we want to use in our calculation. Only 2 elements in our calculation. The elements are D square and N. If you know what is D square, if you know what is N, then you should be able to work on your calculation for RS. Nampak Samsu? You can hear me? Can you follow me?
Yeah. Putus-putus.
Putus-putus. Hari ni kita pergi ke Negeri Sembilan lah kalau gitu. Jambatan putus. Okay. Macam mana hari ni pula tag internet connection tahu bagusnya. Okay. So basically The first thing that we need to do when you go for Spaerman rule will be we want to calculate RS. How to calculate RS? That will be the formula. Once you get your RS, then we need to describe. What is it that we need to describe? We need to describe the direction as well as strength or magnitude of the relationship. That means when we go that route from RS and then we describe, that take care for the descriptive component for Spaerman row correlation. And the second component will be inferential. What is it that we need to do? We are testing for the hypothesis. In this hypothesis, what is it that we are testing for? We are testing on the significance of the relationship. Whether the relationship is significant between X and Y, or whether the relationship between X and Y is non-significant. That is basically what we are testing for. So that will be basically the overall perspective of what we need to understand about Spaerman row correlation. Okay, here I share the two dimension, descriptive dimension as well as inferential dimension. For descriptive dimension, we get RS, whether we calculate or we derive, and then we describe what to describe. We describe the direction as well as the strength or magnitude. That constitute your descriptive dimension for Spaerman row correlation. And for the inferential component, we are testing for the hypothesis, where the hypothesis here will be HO rho S equals 0. What do you mean when we say rho S not equal or rho S equals 0? We are saying that there is no relationship between X and Y. If your HO is true, there will be no relationship between X and Y. If HA is true, then it can be rho S not equal to 0, or rho S more than 0, or rho S less than 0. I mean, the first will be two tail, the second and the third will be one tail. That means depending on the direction, if there is an indication of direction, you go for one tail. If there is no indication of direction, we go for two tail. Right? Because why? Because we our value ranges between -1 to +1 for the T, for the RS, -1 to +1, and if you go for the T ranges between -infinity to +infinity. All right. So that is basically the two dimension, descriptive and inferential. Okay, descriptive dimension. This will be the formula. But now, what is D? What we want is D square, is it right? But before we derive the D square, we need to calculate D. What is D? D here refer to Rx minus Ry. Rx minus Ry. That will be our D. D here refer to the difference between Rx and Ry. Rx minus Ry will give you your D. So what we want is D square. Therefore, we just square the D, we get the D square. So what we want is summation D square. What do you mean by summation D square? The total of the D square value. That is to be inputted into our formula to calculate for the RS. So now the crucial part will be, we want first of all to rank X, we assign that as Rx. We want to rank Y, we assign that as Ry. Before we can calculate D, we need to rank X and we need to rank Y. Okay, now please fasten your seatbelt. Why fasten seatbelt? Because we want to make sure that you get the concept of how to rank X, how to rank Y, how to derive Rx and how to derive Ry. Okay, I will share you a short example here, which will give you the indication of how to rank X and how to rank Y. Okay, now, if you are given here score for X, 16, 18, 14, 18, 21 until 18, and then score for Y starting from 6, 8, 7 until 5. We have how many cases in this case? We have 9 cases. 9 cases for X and Y. So what we need to do now will be, we want to rank X, we want to rank Y. Therefore, we assign Rx for X. Rx here refer to rank for X, and then later on, we assign Ry, ranking for Y. Okay, now, when we want to rank, that means we need to decide whether to assign 1 to the highest value for X or 1 to the lowest value for X. Both are acceptable. But to make life easy, that means to be consistent for all, I would suggest every time that when we want to rank, we assign 1 to the highest value for that variable. So in this case, we want to assign 1 to the highest value for X. So in X, the highest value is 24, is that right? The highest value for X is 24. So that will be assigned as rank number 1. Since we have only one value for 24, then therefore Rx will be 1, because that is rank number 1. Okay, the next will be rank number 2, is that right? But for the second highest will be 21. But here we have two 21, 21, 21. Therefore, we should be rank number 2, rank number 3, is that right? Rank number 2, rank number 3. So therefore, we don't assign here 2 and 3, but instead, if we have a similar number like this, 21, 21, then we get the average of the ranking. That means we assign the average of the ranking. So how to get the average? 2 plus 3 is 5. Divided by 2 will be 2.5, is that right? So this will be rank number 2.5. This is also 2.5. Therefore, we have already ranked 24, 21, 21. The next highest, it will be 20. Is that right? So the next rank will be rank number 4. So that will be 4. Since we have only one value for 4, therefore will be assigned rank 4. And then the next highest will be 8. How many 8? 18. How many 18? 1, 2, 3. We have 3 18. Therefore, this should be rank number 5, rank number 6, and rank number 7. Is that right? For this 18, we will assign the average of the rank. So how to get the average? 5 plus 6, 11. 11 plus 7 will be 18. 18 divided by 3 will be 6. Therefore, 6, 6, 6. Everyone can follow me? Anybody have any question about how we rank the score for X so far? Any question?
Prof.
Yeah.
Prof. Excuse me, Prof.
Yeah.
Can you please repeat it again? How do you get the 2.5 and how for the rank for X?
Okay, Hafiz, just a gentle reminder. Gentle reminder. Sometimes you don't have to wait for me to ask you for a question. If you have any questions, straight away you ask me. I don't mind. But ni kalau saya tak tanya tadi, maknanya you will just keep to yourself, right? Don't do that. Next time, if you have any question, let's say like earlier, when we rank for 21, 21, we get 2.5, 2.5, right? If you have any questions, straight away you post to me. Of course, I don't have any problem to share, but it will be better to ask impromptu, straight away. Okay, so now, let's go back. Okay, let's go back. So when we want to rank, we need to assign one either to the lowest or to the highest value for X. But in this case, we to be consistent for all, we assign one to the highest value for X. So we look at the score for X, we find that the highest value is 24, is that right? So since we have decided that we want to assign one to the highest, therefore, this should be rank number 1. But since we have only one value for 24, rank number 1, therefore straight away for Rx, we assign as 1. That one clear, Hafiz? Hafiz?
Yeah, clear, Prof.
Okay, all right. The next highest is 21, is that right, Hafiz?
Yeah, true.
Okay,
21.
but 21, we have 2, is that right? We have 2 21.
Yes, we have 2.
By right should be rank number 2, rank number 3, is that right? We don't assign 2 and 3, but we assign the average of the 2 ranks, the average of the rank. So that now for 21, the rank will be 2 and 3, is that right? So we just get the average. How to get the average? 2 plus 3 is
5.
5. Okay, how many
5,
cases?
5.
How many cases that we need to divide? 2, is that right?
2 cases.
Because we have 21, 21, 2 cases, is that right? So 5 divided by 2, then we get 2.5, 2.5.
Oh, okay.
How do we get 2.5?
Right,
First of all, we get the total rank, and then we divide by number of cases, right? So we have 2 cases, so 5 divided by 2 will get 2.5, 2.5. We don't assign as 2 and 3, but instead we assign the average of the rank. If we have multiple score, similar multiple score, then we assign the average. Okay, the next will be 20. We have only 120, is it, Hafiz? So that will be the next, the last was 3, therefore this will be rank number 4. Then straight away we assign 4 because we have only one case. But now the next case we have 18, but we have 13 18s, right? So the rank should start from 5, right? So it should be 5, 6, and 7 because we continue the ranking. So now we have how many cases for 18? 3, right? So we add the rank So the rank will be 5
Yes.
plus 6 plus 7. So 5 plus 6 plus 7 is 18. We divide by number of cases 3. Therefore, 18 divided by 3, we get 6, 6, 6. That means if you have similar number, the Rx will be the average of the rank. That means it will be similar. That means in this case, 6, 6, 6. We don't assign as 5, 6, 7, but instead 6, 6, 6. Okay, the next rank will be rank number 8. Is that right? So what is the next highest? 16. Therefore, this should be rank number 8. And then since we have only one case, therefore rank number 8. And then finally, the last update, the lowest value is 14, and then that will be rank number 9. That means now we have rank X into Rx, whereby these are the ranking, right? So let me repeat. In case if you have multiple values, then we get the total rank divided by number of cases. That will be the Rx that we need to assign for the multiple values or multiple score. Okay, now, okay, we have done for Rx. Okay, now please try for Ry. Okay, everyone, take one sheet of paper, even though you have the notes, but don't see the notes, but just work on to make sure that we understood how to proceed to assign rank for X, for Y. X done, we have Rx. Now we want to assign rank for Y, so Ry. So work on your own for a moment, how to rank for Y, and we assign the variable as Ry. We do the same thing, we assign 1 to the highest value for Y, and then we continue until the end. In case you have any question, just like Hafiz just now, you can ask me.
Prof,
Yeah.
can arrange for X we arrange for descending order. I mean 24 we put at the top, and the value of Y followed it. Can or not?
I don't get you, Apini.
Maksud
Because
saya
in order
kalau
in order to rank for X and Y, it should be done separately. I mean independently.
I mean, independently. So we cannot. I mean, X24 we put at the top, then and followed by Y8, 24, 8.
Cannot because why?
Cannot.
24, 8. 8 you refer to the Y? Because Y the highest value is Y the highest value is 9. But better for you to do it separately. No need for you to reshuffle the score, but just assign. The best will be as what I did. I share here. You in the first place you assign the raw ranking here, but the actual Rx or Ry will be assigned in another column. If it is only one case that like 24, you assign 1, here also 1. Is that right? But for 21, we have 2 cases, so 2 and 3, but we assign 2.5, 2.5. So you do like that. I think it will be better. But you don't have to reshuffle the score. When you reshuffle, because these are the score for X and Y. Let's say in your case, let's say Najib is the first person. Your X is 16, your Y is 6. But if you reshuffle, then your score will not be the same, right? You get me? It should be done independently, and you don't have to move the score because each individual, we have the X and we have the Y. We cannot reshuffle the score. So is it clear? Okay, good. All right. Others, kalau ada soalan, if you have any question, then you can pose your question to me. So are we done? Are we done with the RY ranking for Y? Yes, okay. You guys, then we continue our discussion. Okay, so now, in order to rank RY, for those who are not done, you just follow me. We work together. Otherwise, if you have done, then you can counter check your ranking. So as what we did earlier, we assign 1 to the highest value for X, right? So we must do the same thing. That means we assign 1 to the highest value for Y. We don't go for the reverse. So now what is the highest value? 9, right? For Y, the highest 9. Therefore, this is rank number 1. So since only one case, therefore, this is RY will be 1. The next highest will be 8. How many 8? 1, 2, right? That will be rank number 2, rank number 3. So therefore, we assign the average of the rank. So the total is 2 plus 3 is 5. Divided by 2 cases. Therefore, 2.5, 2.5. And then the next highest will be 7. Only one case, that will be rank number 4. And then that is RY will be 4. And then the next highest will be 6. How many 6? 1, 2, 3. Right? So that means this will be rank. The last was 4. Now will be rank number 5, rank number 6, and rank number 7. So we do the same thing, we get the average. So 5 plus 6 plus 7, 18. Divided by 3 cases. Therefore, we have 6, 6, and 6. And then the next will be 5. How many 5? We have 2 5. Therefore, this will be 8 and 9. So since we have two score here, so therefore we get the average. So 8 plus 9 is 17. 17 divided by 2 will be 8.5, 8.5. Now we have Rx and Ry. What we want to calculate, Shuhada, is we want to calculate D, remember? Because the formula is Rs equal 1 minus 6 summation D square divided by N within bracket N square minus 1. So now we want to calculate D. Earlier, what was the formula, Shuhada? What was the formula that we share to calculate for the D?
Rx minus Ry.
That means we create another column here for D, where how to calculate D? For every individual case, we minus Rx minus Ry. So in this case, 8 minus 6 will be 2. Right? 6 minus 2.5 will be 3.5. 9 minus 4 will be 5. And then 6 minus 8.5 will be minus 2.5. 2.5 minus 6 will be minus 3.5. 4 minus 1 will be 3. And then 1 minus 2.5 will be minus 1.5. 2.5 minus 6 will be minus 3.5. And finally, 6 minus 8.5 will be minus 2.5. That means we get the score for D. How to calculate D? For each case, we get Rx minus Ry. And then finally, we are not interested in the D, in the formula. In the formula, we want D square. Is it right? So we create another column, D square. So we square each value for the D. So 2 square will be 4. 3.5 square will be 12.25. And then 5 square will be 25. And then 2.5 square will be 6.25. And then 3.5 square will be 12.25. And then 3 square will be 9. 1.5 square will be 2.25. 3.5 square will be 12.25. And then 2.5 square will be 6.25. Right? This are the score for your D square for each of the 9 cases. So what we want in the formula is summation D square. So what is summation D square? It's just the total of summation D square. Right? So that means if you were to total up the last column, that is the value that we want in our formula, summation D square, which is in this case happen to be 89.5. 89.5. That will be the D square, summation D square. Right? That is how we do our ranking. That is how we calculate for the D. That is how we calculate for the D square. And that is how we calculate for summation D square. Any question about that? If you go step by step, if you were to practice, you have enough practice, then naturally you should be able to do the calculation easily, right? But just a matter of do it carefully so that you will not make any careless mistake. Unnecessarily careless mistake will result in wrong answer to the question. Okay, so now that will be summation D square. So we skip the calculation there for a moment. Okay, now we are talking about relationship between variables, right? I mean between x and y. So we can present the relationship in terms of scatter plot or scattergram. This is one, this is the second, this will be the third. So this is A, this is B, this is C. If it is A, if we have scatter plot like A, would we expect to be the relationship to be positive, negative, or no relationship if it is A?
Positive relationship.
That's right. What do you mean by positive relationship? If for positive relationship, if x is here, y is here, right? But what happens if x increases? If x increases, y also increases. I mean, increase in x, increase in y, that will be positive relationship. Or decrease in x, decrease in y, that also indicate positive relationship. And that is what we meant by positive relationship. What about B? If you have a scatter plot like B, what should be the nature of the relationship? Positive, negative, or no relationship?
Negative relationship.
That will be negative. That's right. I mean, for negative relationship, if x is here, then y will be somewhere here. Is it right? But what happens if x increases? Y will decrease. Yeah, is it right? So increase in x, decrease in y, that is a negative relationship. Or decrease in x, increase in y, that is also a negative relationship. I mean, there is some form of relationship between the two variables. Increase, 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 decrease. All right. Okay. What about C? If your scatter plot is like C, so should it be positive, negative, or no relationship? Shengnan, you want to answer this?
I think it is no relation.
That's right. I mean, it doesn't indicate any pattern of relationship, right? So in this case, just have a distribution for the dots, which doesn't indicate any indication of direction. Therefore, there will be no relationship between x and y. That is basically what we need to understand about when we talk about relationship between variable. It can be positive, it can be negative, or it can be no relationship between variable, right? So that is the direction that we would expect to see for relationship between two variable, any two variable x and y. Okay, when we calculate for the RS, as I did mention earlier, your RS ranges between -1. The lowest will be -1, and the highest will be +1. It should be just within that range. It cannot be more than 1. It cannot be less than -1. The range is only between -1 to +1. Whereby, if we look at the plus and minus here, the plus and minus just to indicate the direction. But the absolute value of the RS will indicate the strength of relationship between X and Y. The sign will indicate the direction. So then let's say if you have RS equal -0.75, based on Guilford rule of thumb, what can we see about the strength relationship between X and Y if it is -0.75? Anybody?
High.
High relationship. High. We cannot say low. We cannot say negligible. Is it right? Because the minus just to indicate the direction. That means there is a negative and high relationship between X and Y. We cannot say there is a negligible relationship, because if you were to look at -0.75, it is less than 0.2. Is it right? Less than 0.2. But the sign will just to indicate the direction. The absolute value of your RS will indicate the strength. So that means -0.75, the absolute value is 0.75. That 0.75 is the strength. Based on Guilford rule of thumb, that should be a high relationship. What about the minus? The minus to indicate a negative relationship. So what we can say will be there is a negative and high relationship between X and Y. Right? So hopefully everyone is clear, because many years back, one of the questions that I asked a student, okay, please interpret the strength of relationship between two variables when R equal -0.75. Some students says negligible. Why the student says negligible? Because he or she take into consideration both -0.75, which is happen to be lower than 0.2, is that right? So according to Guilford rule of thumb, if this less than 0.2, negligible. But that is not the right procedure for your interpretation. The sign will just to indicate the direction, whereas the absolute value will indicate the strength. Okay. Hopefully take care. This is what we have discussed, what we have used earlier last week. Guilford rule of thumb: less than 0.2, negligible; 0.2 to 0.4, low; 0.4 to 0.7, moderate; 0.7 to 0.9, high; more than 0.9, very high relationship. So what does it mean here? That means anything that is less than 0.2 is considered to be negligible relationship. 0.2 up to before before 0.4. Before 0.4, that means 0.399999 is still considered as low. 0.2 up to before 0.4 will be low. 0.4 to before 0.7 will be 0.69999, still considered as moderate. That is the interpretation. Otherwise, if it is 0.4, should it be low or moderate? The answer is it should be moderate. I mean, 0.2 to 0.4 here refer to 0.2 up to before 0.4. That is low. 0.4 up to before 0.7 will be moderate. 0.7 up to before 0.9 will be high. 0.9 onwards will be very high relationship. Okay, so that will be if we were to interpret the strength of relationship between X and Y using Guilford rule of thumb, right? Okay, the inferential component, on the other hand now, the inferential component is we are testing for the hypothesis, right? So we have done the descriptive component. Now we proceed for the testing for hypothesis. So step number 1, state HOHA, regardless whether your sample size is 10 or more, will always be state HOHA, and the HOHA will be the same. Second step, either we report RS or we calculate T. We report RS or we calculate T. When to report RS? If the sample size is less than 10. When to calculate T? When the sample size is 10 or more. Right? That will be second step. Third step, determine critical value. That means if your sample size is less than 10, you go to your Spaerman row table. Spaerman row table on page 14. But if your sample size is 10 or more, then we go for T table in step number 3. Step number 4, we make our decision by comparing the calculated statistic against critical value. And then step number 5 will be our conclusion. Now, that will be the 5-step procedure in testing for hypothesis. But whether you need to go for step number 2, step number 3, whether this depend on sample size, less than 10 or 10 or more. And then we decide on whether in your step number 2 or step number 3, whether to refer to the RS or to calculate the T, whether to refer to the Spaerman row table or to refer to the T table. But the rest will be the same, right? But that will be the step. The hypothesis, step number 1. We always write HO rho S equals 0. What does it mean when we say rho S equals 0? What it means that there will be no relationship between X and Y. Remember when we discussed about hypothesis earlier, what is null? Null always say no, no, no. If it is different, no different. If it is relationship, no relationship. So we always write as rho S not equal to 0, no relationship. The alternative hypothesis can be either rho S not equal to 0, which will be 2 tail, or rho S more than 0, 1 tail positive, rho S less than 0, 1 tail negative. That means we choose only one, not to present all the 3, but you choose only one depending on the question. Step number 2, we want to calculate the test statistic. The test statistic depends on sample size. If your sample size is less than 10, then we just report the RS. However, if your sample size is 10 or more, then we calculate T using the formula T equal RS minus rho S divided by square root of 1 minus RS squared divided by N minus 2, where our degree of freedom for the T will be N minus 2. The degree of freedom is given here. Even though it is not in your formula sheet, but remember, write somewhere, degree of freedom is N minus 2 for your T test in this particular step number 2, right? That will be test statistic. Step number 3, to determine critical value. If your sample size is less than 10, then we go for this table, this Spaerman row table, where the one on the left will be 2 tail, the one on the right is 1 tail, and you are given alpha 0.05, 0.01, 0.05, 0.01. But here, we don't need to determine degree of freedom. The decision is based on sample size, not degree of freedom. Here, N is sample size. That means whatever the sample size, you just locate the value and then locate the alpha. And whether you are testing for 2 till or 1 till, then you get or extract the critical value accordingly. That will be if your sample size is less than 10. But if your sample size is more than 10, then we go for the t-table, our normal t-table that we have been using before when we discuss for t-test. T-test, we use the same table, is that right? I mean, this will be the table to be used if your sample size is 10 or more in step number 3 to determine critical value. Step number 4, decision. If it is less than 10, we just compare RS calculated against RS critical. If it is bigger than reject HO, less than fail to reject HO. That will be if you are using your, if the sample size is less than 10. But if you are using SPSS, we just compare significant RS against alpha, less than, reject, more than, fail to reject. Okay. If your sample size is 10 or more, then for manual calculation, we compare T calculated against T critical, bigger than, reject, less than, fail to reject. If it is SPSS, we just compare significant RS against alpha. If it is less than, reject, more than, fail to reject. The same decision criteria, see? It's just a matter of the statistic that differ. Okay, and then finally, the conclusion. If you were to reject the null hypothesis, what can we conclude? The general conclusion is there is significant relationship between X and Y at whatever the alpha. If you were to reject the null hypothesis, that means the relationship is significant. But if you fail to reject the null hypothesis, then the conclusion will be, the general conclusion will be, there is no significant relationship between X and Y at whatever the alpha. That you need to indicate what are the variable, whether it is significant or non-significant, what are the variable, as well you need to indicate what is the alpha in your conclusion. And that take care for the whole that you need to know about Spaerman row correlation. So if you follow from the beginning until now, that are the discussion of what you need to understand about Spaerman row correlation, the purpose, the requirement, the 2 dimension of Spaerman row, descriptive, inferential, and we have gone in detail what to do when we go for the descriptive component, where we calculate RS using the formula, RS equal 1 minus 6 summation D square divided by N square minus 1. And then once we calculate for the RS, or we derive the RS from the SPSS, then we describe. What is it that we need to describe? Direction and strength. And then for the inferential component, we have 2 procedures. The first procedure, if your sample size is less than 10. The second procedure, if your sample size is 10 or more. So that are basically what you need to understand. What is our time now? Our time is 10:15. Okay, maybe we proceed to example. This example is for n less than 10. I mean, for less than 10, this will be how we need to respond to the question. Okay, this is the example here. Okay, are we ready for the example? Are we ready for the example? Or you have any question to ask? Example here, okay, example. A study was done to determine relationship between loyalty and performance. Loyalty is the IV, performance is our DV, because normally we spell out IV and DV. So IV will be presented first, followed by DV. So loyalty and performance, therefore loyalty will be the IV, performance will be the DV. Data collected from a randomly selected sample as presented in the following data. I mean, the data set is as such. We have the 9 cases, that we have done for the ranking earlier, remember, X and Y. And then this question, we have 3 questions here. Question number 1, calculate the appropriate correlation coefficient. I mean, for your final exam, the question will be something like this. That means we don't declare whether you need to calculate for Spaerman or Pearson or simple linear regression. We just simply say calculate appropriate correlation coefficient. But you need to decide whether should we respond using Spaerman or Pearson or simple linear regression. How to decide? We can discuss that one later. That will be the first question. But of course, in this particular case, because we are discussing on Spaerman, therefore, we would expect to calculate RS. Question number 2, describe the nature of relationship between the two variables. And number 3, test the hypothesis on the relationship at 0.05 level of significance. Right? So that means when we want to test for the hypothesis at 0.05 level of significance, we need to decide, are we going to test for two tail or are we going to test for one tail? Any question, any response to this? Are we going to test for two tail hypothesis or one tail hypothesis test?
This one, two tail.
Two tail. Why two tail, Najib? The answer is correct. Why? But why two tail?
Because the hypothesis on the relationship at 0.05.
So what make the you decide that this should be two tail, not one tail? What is the keyword that you are looking for?
No direction. There is no.
I mean the keyword is there any direction or no direction? In this case, it doesn't indicate the direction, is it right? Let's see if the question says test the hypothesis that there is positive relationship between loyalty and performance. That indicate direction. But now we are just testing for relationship. We don't care whether it's positive or negative. Therefore, this call for two tail. Okay, now in order to respond for this, the question to answer question number 1, to calculate Spaerman rho correlation. So first of all, as what we did earlier in our example to rank X and Y, given X and Y, in this case here, X and Y, we rank X, we rank Y, and then we calculate D, we calculate D square. And we have already calculated for this summation D square, remember? Okay, this is the value that we want, right? So once we get this value, then we use the formula RS equal 1 minus summation D square divided by N square minus 1. So we just plug in the value, which is equivalent to 1 minus 6 multiplied by 89.5, which is our summation D square, divided by N, 9, and then 9 square is 81 minus 1. And if you were to solve for this, which is equivalent to 1 minus 537 divided by 720, which is equivalent to 1 minus 0.7458, which is equivalent to 0.254. That will be, that means to answer your question number 1, there is no in between, right? There will be no output in between. You just question number 1, calculate RS, and then you just show your calculation. Then it becomes neat and tidy and will be more systematic. But the current assignment, inshallah, I've seen pages and pages of output. Right, but the output will be placed at the back, right? Okay, that will be question number 1, where RS equal 0.254. What is question number 2? Question number 2, we want to describe the nature of relationship based on RS. So what is the sign in this case? Positive or negative? When there is no sign, that means it's understood that is positive, because we don't write positive. If you write positive, that means something wrong somewhere with you, right? Because by default, if you don't write anything, understood that is positive. I mean, what we can say here will be there is a positive. And what about the strength? 0.254 fall between 0.2 to 0.4, is it right? According to Guilford rule of thumb, 0.2 to 0.4 is considered to be low. Therefore, we say there is a positive and low relationship between what? Between loyalty and performance. And that will be the answer for question number 2. Positive and low relationship between loyalty, the two variables are loyalty and performance. You don't write as performance and loyalty, because normally when we write IV and DV. So our IV is loyalty, DV is performance. Okay, that is question number 2. Question number 3, we want to test the hypothesis on the relationship at 0.05 level of significance. Therefore, step number 1 will be, we want to state the null and alternative hypothesis. So what should be the null and alternative? The null will be HO rho S equals 0 against the alternative hypothesis rho S not equal to 0, because we are testing for two tail. Step number 1. Step number 2, no need additional calculation. We just report RS. What is our value for RS? RS equal 0.254. That will be our step number 2. RS equal 0.254. Where do you get 0.254? From our earlier calculation in question number 1. Step number 3, we go to the table, we go to the critical table for Spaerman row. In this case, we refer to on page 14, two tail on the left, and alpha 0.05, and then the n or the cases or sample size equal 9. So if you refer to the table, RS at 9 and 0.05, the value is 0.683. Okay, please check. You get 0.683 if you open page 14. Page 14 at 9.683. That will be your critical value. Step number 4, we want to make our decision. In order to make the decision, we just compare RS calculated, which is 0.254, against RS critical 0.683. What should we do here? The calculated happen to be smaller. If it is smaller, reject or fail to reject?
Fail to reject.
Fail to reject. So the answer is already there, is it right? Therefore, fail to reject HO. I can see some of you, you want to put the therefore. You don't have to write up in using your pen. You can go to your symbol and then look for therefore. And I mean, it will be more presentable. If you were to write using your pen or pencil, then the rest you type, but for therefore you use the pen, pencil, doesn't look nice. Therefore, look for the symbol and then use the symbol accordingly. All right, so in step number 4, why we fail to reject? Because our calculated RS is smaller than RS critical. What can we conclude then? In step number 5, there is no significant relationship between loyalty and performance at 0.05 level of significance. At 0.05 level of significance, we fail to reject the null hypothesis. Okay, Najib, since Najib is in front of me, if we fail to reject the null hypothesis at 0.05, what happens if you are testing at 0.01? What should be, if you don't look at the table, the critical value, what should be your decision? Reject or fail to reject?
At 0.05.
At 0.05, we fail to reject. At 0.01?
Okay. 0.1 may or may not.
For sure, because 0.05 is less stringent. 0.01 is more stringent, right? That means at 0.05, less stringent, you fail to reject. At higher stringent level, you for sure will fail to reject. But if let's say now, if you were to reject at 0.05, what happens if you are testing at 0.01? Then you may or you may not reject because at 0.1 is more stringent. Najib masih belum capture lagi so make sure practice, right? Okay, so that will be how we respond to the manual calculation for our example, whereby our n is less than 10, where n equal 9, and we have two variables that we are testing for the relationship, loyalty and performance. When we go through the process, we find that the RS equal 0.254, and then based on that value, we can describe the nature of relationship, which happen to be positive and low. And then when we test for the hypothesis, we fail to reject. Why we fail to reject? Because the calculated RS is smaller than critical RS. Therefore, when we fail to reject, then the conclusion will be there is no significant relationship between loyalty and performance at 0.05 level of significance. Okay, that is for manual calculation. And now it's approaching towards 10:30. Okay, let's take our break. Unless you have any question, let me open for plenary session if you have any question to ask. Otherwise, we go for our break and we come back for our second half. Okay.
Go for our tea break.
Any question for clarification? Naziha, ada soalan? Okay, boleh. Okay, good. Adila, what happened hari ni gambar still je, tak open your camera. Sebab kamera apa ni gambar still tu nampak kemas lagi ya, dengan tie-nya, dengan apa ni.
Line saya tak.
Oh, line. Okay. Line. Okay, tak apa. It's okay. Any question? Okay. Panel 1, no question. Okay, let me go to panel 2. Any question in panel 2? Subhash, any question Subhash? Clear? Aiman? Apa ni mataku? Aiman? Clear, Aiman? Oh, bukan ya? Aiman apa? Ellie Esterina, any question? Clear, okay, Alhamdulillah. So that means if there's no question, then we stop here. Okay, now is What is our time now? Oh, okay, our time is 10:26. Okay, we come back at 10:50. We come back at 10:50. Is it okay? Okay, we start our session. We come back at 10:50. So at 10:50, as much as possible, please and join the session prior to that 10:50 so that we can move together. Otherwise, as what happened this morning, I didn't realize that there are few of you waiting in the waiting room, but you need to wait there for quite some time. So if you come early, then I can admit everyone in the session so that we can go together, inshallah. Okay, Assalamualaikum warahmatullahi wabarakatuh.